In this video, we are going to see the classification of solids. Solids, they are broadly classified in two types. First is crystalline and second is amorphous. Now, what is crystalline means? For that, let us take help of the structure. So here, if I see the arrangement of atoms, ions or molecules, if I see, they follow a regular pattern in this way. Every atom is attached to the other atom following a definite pattern. You can see here that every atom is following a specific or a definite pattern to each other, and this pattern extends all over in all the direction following the same pattern. So if I see this pattern is followed in this direction as well as behind, front. So this is in all the three dimensions. Whereas in amorphous, if I see, they are just stacked. Stacked means, student, they are placed one above the other. So if I see the structure here, they are present in any of the pattern like this, one above the other. So this is a random arrangement of the atoms. Student, this best example what you can have is your school assembly. When you stand for the school assembly, you all stand in a line following a definite pattern. So this is what we see in crystalline solids. Whereas if I see a bus stop, or when you are getting late for your college and you try to get into the bus, then the people who are standing there, they have this type of arrangement. So the two types, the solids can be classified is crystalline and amorphous. So what you understood here under crystalline, that they are following a definite pattern which is over and over in all the directions. So this arrangement is for a long distance. We call this as a long range arrangement. Whereas if I see here, they are having a definite arrangement. If I see this atom and three atoms, they are following a definite pattern. After that, the pattern changes. So this we call it as the short range pattern. So they follow a short range pattern. Second very important thing, if I try to cut this crystalline solid by using a sharp tool, then what will happen if I cut this in this way from here? I will get two pieces. Now the two pieces will be like this. If I am cutting the above crystalline solid in this way, then I get two halves. Now the two halves they have, you can see here, they have plain surfaces or they have smooth surfaces here. So if I see the arrangement here, they are after the two pieces which are formed, they are having smooth surfaces here. But if I try to cut an amorphous solid, if I cut it in this way, you can see that some atom is getting splitted to this side. So what will be the splitting like is some atoms, they will have this type, they will get cut. So they will have some irregular surfaces here, and therefore the pieces, they will not have smooth or plain surfaces. So this is the second point of difference between crystalline and amorphous solids. Let us recall the first point, that is they have a definite arrangement of atoms, ions or molecules, and this definite arrangement is for a long range. Whereas here the atoms, they are just piled one on the other, so there is no definite pattern of the arrangement of atoms, ions or molecules, and so we say that they have short range pattern. Second is, if I try to cut a crystalline solid by using a sharp edge tool, then I get two pieces with smooth and plain surfaces, while here they will split up into two pieces, but they will have irregular surfaces. So this is the second point of difference. Let us see the third type of difference, what you can see here. If I try to heat a crystalline substance, then it will melt at a fixed temperature. Means they have a specific characteristic melting point. Whereas in amorphous solid, if I heat them, they will, after some time, they will become soft and remain soft at a particular temperature. Means they melt at a wide range of temperature. Like say for example, if I take rubber or glass and I heat it, then first it will become soft and then it will remain in that molten form for a long time. So they melt at a wide range of temperature. While the crystalline solids, they will melt off at a fixed temperature. So when I say crystalline solids, they have fixed melting point, they have specific heat of fusion also. Specific heat of fusion. While they don't, amorphous solids, they don't have specific heat of fusion. So next very important point is about isotropy and anisotropy. Now students, what is the meaning of isotropy and anisotropy? In case of amorphous substances, properties like electrical conductance. Let us see the properties what I am talking about. Electrical conductance, refractive index, thermal expansion. Those are the properties what we will study for anisotropy and isotropy. Thermal expansion, etc. They are, if I see them, they will be identical in all the directions because the arrangement is like this. If I see the electrical conductance through this direction, or through this direction, it will be same. Because there is no regular arrangement and the atoms, they are packed one on the other, and therefore all the properties, they will remain same. Which properties I am talking about is electrical conductance, refractive index, thermal expansion. Those are the properties that will remain same for amorphous solids. And therefore, as the properties, they remain same, we call them as isotropy. And the substances, that is amorphous solids, exhibiting this isotropy, they are called as isotropic compounds. Now let us see what is anisotropy. So the fifth point is, what is anisotropy? An means different. So when a crystalline solid, let me show you one diagram, students. If I want to show this anisotropy, I can show this diagram here. You can see this diagram here. If a solid is arranged in this way, here you can see there is a regular arrangement. I have taken two atoms. This is the row of atom A and the red one, they are atoms B. So if I see the arrangement of the atoms, you can see that there is a regular arrangement in all the directions. Now if I observe the properties along OP, properties will be different because it will be because of atom B. Let us call those red atoms as B and the black atoms as A. So here if I see the red atoms through this OP direction, if I see, properties will be different. If I observe through the direction that is MN, it is because of the black atoms, so the properties will be different. Same if I observe along QR, properties will be black, red, you can see the arrangement, so they will be different. So the properties changes depending upon the direction along which or through which you observe the solid. This type of property which changes along the direction of observation, that is called as anisotropy. So this type of anisotropy is seen in crystalline solids. So that is what the next point is, that crystalline solids, they are anisotropic in nature. While amorphous solids, if you see, they are isotropic in nature because they have the same properties whatever is the direction of observation. So this is the major difference between this. Let us come to the next one. When I talk about the particular crystalline solids, I say that they are true solids because the properties, they all are fixed. While the amorphous solids, they are, now I can't say they are false solid, but they are pseudo solids, or usually we call them as supercooled liquids. So those are the points of difference between the crystalline and the amorphous solids. Let us recall a chart which will help you to distinguish between crystalline solids and amorphous solids. So take a screenshot for this. It will help you to write the distinguished properties between crystalline and amorphous solids. Students, if this question is asked, this can be for 2 marks. So you can write any 4 properties out of this. So let us see the first one, that is definition. Crystalline solid is a homogeneous solid where the constituent particles, that is atoms, ions or molecules, they are arranged in a definite repeating pattern. While amorphous solids, they are also homogeneous solids, but they do not have a well-developed perfect arrangement of atoms, ions or molecules. The second is shape. Crystalline solids have definite characteristic geometrical shape due to the orderly, regular, long-range arrangement. So we have seen what is the long-range arrangement means. While in amorphous solids, they have irregular shape and lack the characteristic geometrical shape due to short-range arrangement. Next is melting point. You know that they have sharp and characteristic melting point. Here characteristics means, student, any pure solid substance, it has a fixed melting point. So, and it is the characteristic of that substance. While in amorphous, they do not have sharp melting point and so they soften over a long range of temperature. As I said, melting point, if it is sharp, it will have a definite characteristic heat of fusion also. While amorphous solids, they do not have characteristic heat of fusion. Next, very important point what we have seen, that crystalline solids, when they are cut with a sharp edge tool, they split into 2 pieces and the 2 pieces, they have smooth plane surfaces, which is not seen for amorphous solids. Right, students? Next, very important is anisotropy. When I say crystalline solids, they show different properties when they are seen through different directions, means they are anisotropic in nature, while amorphous solids, they are isotropic in nature. Now next, nature if I say, then the crystalline solids, they are true solids, while amorphous solids, they are pseudo or supercooled liquids. Order of arrangement, in crystalline solids, they have long range order, while amorphous solids, they have short range order. Now the immediate thing, what can be the examples for crystalline and amorphous solids? So crystalline solids, we have crystalline quartz, copper, silver, iron, zinc sulfide, sodium chloride, that is common salt, potassium nitrate, etc. While amorphous solids, you can have glass. Best example is glass, which is a supercooled liquid, rubber, plastic, you have your butter, cheese, tar even. They are the examples of amorphous solids. So just take a glance on this and we will see the difference here. So any 4 points will help you to get 2 marks for this type of questions. Now, if you like this video, please like, share and comment. Please subscribe my channel to get more such videos. Thank you, students.